Unit 1, Lesson 1, Introduction to Matter. The essential question for Lesson 1 is what properties define matter? And so your book divides up things by units and then lessons. And so in your book, you start out with engage your brain. So pause the video, find page 5 in your textbook, and then write into the answers. This is to figure out what you know. So don't look up the answers, is what you know right now. Matter is anything that has mass and takes up space. This is a very important vocabulary word, so take out a highlighter and highlight the definition on page 6. If I were to pick up your textbook, these pages, I would be looking for to see if you did this in the lesson. So light and sound are not matter. And so this is a quote by Mr. Prodham that says, light is both a particle and a wave. Light has properties of both a particle and an electromagnetic wave, but not all the properties of either. It consists of photons that travel in a wave-like pattern. The debate has raged for generations amongst the giants of the physics community regarding the nature of light, namely whether it is a particle or an electromagnetic wave. So think about what you know about sound and then answer the question, why is sound not considered to be matter? And you have the space on page 6. Write the question and then write your answer. So as you read this section of the book on page 6, you're asked to ask a question called active reading. And so it's labeled number 5, and it says, how can you tell if something is matter? So pause the video and answer that question. So you could put, one thing you could put is that you can measure it, and if it has mass, it is matter. Now we're going on to what's the matter, pages 6 through 8 in your textbook. And one of the key things for this section is that you get a strong understanding and are able to define what matter is. So on page 6, they ask you to look at this picture, and number 6, called Visualize It, asks you to name 3 examples of matter found in the photo. So pause the video and write down 3 examples. Some examples that I put were water, air, trees, kid, backpack, grass. So in What's the Matter, you have 3 things that it's going to go over. It's going to define mass and weight, help you determine the difference between the two, and how do we measure them. So mass describes the amount of matter in an object, and you need again highlight this definition on page 7. And it gives you 2 examples of the balloon that is filled up with air and the balloon that has no air. And so in your book, it shows you a scale and shows you that the blown up balloon has more mass, indicating that the air that you put into the balloon has mass. Same thing with the picture on the left. It's a simple scale, and you can see that the balloon that has air put into it has been pulled down more. That means it weighs more, it has more mass. Here's that example from your book blown up so that you can see it better. The balloon that's not blown up has 0.005 grams, and the one on the right that has air in it has 0.1 grams. Same example, just blown up so you can see it better. And we talked about this before, that mass does not equal weight, and that people tend to use them interchangeably, but that's incorrect. Weight is the measure of the gravitational force on an object. And again, highlight this definition on page 7. You're going to be using these parts of your textbook to help you as a reference to study for the assessment at the end of this lesson. And so it's important that you're highlighting and taking notes as we go along. So we talked about this before, but we'll go ahead and reference it again, that mass does not change depending on your location. The person in the example will always be 50 kilograms, whether they're on Jupiter, Mars, the moon, another galaxy, they're always going to have the mass of 50 grams. But as they change locations on different planets, there's a different amount of gravity pulling them to the surface. So weight is different depending on location. It depends on the pull of gravity. And here's some comparisons of the surface gravity of some planets. So if you were on Jupiter, you would weigh about 2.5 times more than you would here on Earth. But if you traveled to Venus, Uranus, Mars, Mercury, the moon, you would weigh less. You'd still have the same mass, though. That wouldn't change. So as you read through page 7 in your textbook, you have another active reading. And the active reading asks you to explain, why do astronauts weigh less on the moon than they do on Earth? So pause the video and answer that question. And you need to put something about in your answer that the pull of gravity is less on the moon, that the mass stays the same, but the moon has less of a gravitational pull on the astronaut. Next, you have a visualize it, which has a triple beam balance. And it asks you to infer, would this balance give the same value for mass if used on the moon? Explain your reasoning. So pause the video and then take a moment to answer the question. So the answer is yes. The pull of gravity on the mass on the scale will be the same pull if you move the scale to another planet. So if the mass of the amethyst that's on the triple beam balance was 125 grams, if you moved it to the moon, it would still be 125 grams. Now, if we put it on a scale, which measures the weight or the force of gravity, it would be less. But if we're just measuring mass, it's going to be the same. So the triple beam balance would work the same. Here's an example of a spring scale. And so a spring scale actually takes into account the force of gravity, the downward pull on a mass due to gravity. So a spring scale measures weight.